So in reading this question, X is the number of units that are being sold. So X shirts and the price per shirt is given by P. And just to make sure that there's not any confusion, let's make this a little p. So that is our price per shirt. And then they give us the cost function. So to find the revenue function will always be X, so the number of units sold times the price per unit. So revenue is XP, again, number of units sold, and then times the price per unit. So in this case, our number of units is represented by X. So revenue function will look like X times the price per unit, in this case the price per shirt, is given by this little p function, which is 150 minus 0.75x. So our price will be 150 minus 0.75x. So in simplifying this, we will simply distribute, and then we will get that our revenue function is equal to 150x minus 0.75x squared. Now, once we have the revenue function, because we also have the cost function given here, we can put those two together to find our total profit function. So our profit function, again, is the revenue minus the cost. So we'll take our revenue, which is 150x minus 0.75x squared. And then remember, anytime we have minus c, we have to subtract off the entire cost function. So everything is going to get a change in signs. So again, we started with positive 4,000, so we'll have a minus 4,000. We started with positive 0.5x squared, so we'll have a minus 0.5x squared. Now, before we take the derivative, it can sometimes be helpful to just combine your like terms. So the negative 0.75, the 0.5x squared, those can be combined together. So you have negative 1.25x squared minus 4,000. And that is our profit function. Now, you know what's coming. What we want to do is we want to try to figure out how to maximize our profit. And if we are trying to maximize our profit, we are simply going to take the derivative of the function we're trying to maximize and then set it equal to 0. So what we will do is we will take our profit and we will take its respective derivative. So 150x is just going to become 150 minus, if I bring the 2 down and multiply 2 times 1.25, I get 2.5x, and then the negative 4,000 becomes 0. So I set this equal to 0. This is where I'm finding my critical numbers in order to find the relative min and relative max. So if I solve, again, a linear equation, x to the first, I can move the 2.5x over to the other side and just focus on isolating the x. No factoring needed here because of the fact that it's x to the first. So we divide by 2.5 and we get x is equal to 60. Now, remember that X represented the number of units that were being sold. So in this case, shirts were being sold. So this says that the number of shirts that the company needs to sell to maximize profit will be equal to 60. So they need to sell 60 shirts in order to maximize their profit. Now, to answer the question of what is their profit, the max profit will come from plugging in 60 into the profit function. So we will find that the max profit is P of 60. So again, we go back to the profit function and plug in 60. And that will give us our profit at the 60, which we have shown and above, will maximize our profit. And I said we've shown above, and again, you would have to draw a number line and make sure that 60 really is the max, but it will result in a max, and that will give you that your max profit is $500. All right, then they ask what is the price per shirt that the company has to charge to maximize profit. Now, at the very beginning of the problem, they gave us that little p, the price per shirt, was 150 minus 0.75x. So to find the price per shirt to maximize profit, we will need to plug in 60 in for x. And when you do that, you get $105.